Exploring space comes with a lot of unknown and weird phenomena, and NASA has kept a great deal of them from the public. Some of this secret info is often taken by space probes like Voyager 1 and 2, after which they send back messages as photos for the space agency to observe. What we don't know is that some of these photos contain secrets within them that are never revealed to the public. What kind of images are these, and why does NASA keep them from us? Could aliens be a part of these photos? Join us as we explore secret Voyager images that we weren't shown. The twin probes built by NASA, Voyager 1 and Voyager 2, have marveled the world of science incredibly with the discoveries they have made. In fact, scientists and astronomers all around the world have commended them, naming them a gift to science that keeps on giving. However, some of the photos taken by these space probes are a bit suspicious, as the National Aeronautics and Space Administration always tends to keep them a secret. One such photo is this Voyager 1 image of Jupiter's moon, Io. Io is the most geologically active place in the solar system, and if astronomers were to vote for the most un-Earth-like world, Io would be among the top 1%. And another thing is that Io has one bizarre feature: volcanoes. Not just one, but a huge amount scattered across the planet. These volcanoes form due to the planet's huge gravity that stretches Io's interior in a process called tidal heating. This process melts rock into liquid magma, which then finally builds up enough pressure before bursting to the surface. Due to the massive quantity of volcanoes on Jupiter's moon, it looks like a huge ball of cheese, or somewhat related to a terribly unappealing pizza. It must be puzzling to discover that there are volcanoes outside our planet, but when NASA took this photo and studied it to see if it's active or not, they knew at once that it must not be revealed to the public. What did they see? The photo was taken by Voyager 1 and studied by the officials at NASA, and it showed one of the active plumes of the volcano Loki. Active volcanoes are not something we hear of often in our solar system because space is mostly filled with objects that are geologically dead. But when the Voyager spacecraft explored Io in the late 70s, it discovered more than 5 active eruptions during its flyby. It even captured one on film. Since then, more than 150 active volcanoes have been detected and mapped, and about 400 are theorized to exist. Of all these volcanoes outside our planet, the most impressive of these volcanoes is the one called Loki. Named after the Norse god of mischief, Loki might not be the biggest volcano in our solar system, but it is the most powerful to exist without a doubt. This volcano has a groundbreaking diameter of 202 kilometers, but the molten underground lava lake feeding Loki its material is what mesmerizes scientists and astronomers. Due to this, Io is capable of shooting lava with enough power that can send it hundreds of miles into space. Loki's power is one that got the attention of the entire science world upon discovery, and as a result is often watched by scientists and astronomers. Now, you might think that the reason why Io's most powerful volcano is often watched is due to its eruptions. Well, yes, but not for that exact reason. Loki likes to keep a schedule when it comes to eruptions, as astronomers have noticed, and if their speculations are correct, it would erupt soon and it might be more powerful this time. For a volcano that shoots lava hundreds of miles into space, imagine how far it would shoot lava during its most powerful phase. Julie Rathbun, a senior scientist at the Planetary Science Institute, once displayed a poster at a congress in Geneva. This poster showed how easy it is to predict Io's eruptions, as the volcano is so bright in the infrared that telescopes on the Earth can easily detect it. This is completely true because studies over the last 2 decades have depicted that Loki brightens during its eruptions. In the 1990s, Loki was studied and scientists found out that it erupts every 540 days. When recent studies were carried out, it was seen to occur every 475 days. This was a prediction that Rathbun made correctly, but not all predictions correlate easily. It is usually hard to predict the eruptions of volcanoes due to several factors that can cause eruptions, but Loki is different. We think that Loki could be predictable because it is so large, Rathbun said. Because of its size, basic physics are likely to dominate when it erupts, so the small complications that affect smaller volcanoes are likely to not affect Loki as much. Still, Loki is not rigid, and even Rathbun, who once predicted its eruptions, acknowledged it. Loki is named after a trickster god, and the volcano has not been known to behave itself, Rathbun said in a statement. In the early 2000s, once the 540-day pattern was detected, Loki's behavior changed and did not exhibit periodic behavior again until about 2013. So you see, the volcano lives up to its name, but scientists were still not ready to give up. That birthed a new study in which Catherine de Clear, a planetary scientist, and her team examined 3 decades of observation of the ebb and flow of Loki. It was done in a bid to find patterns that might explain the volcano's schedule of activity to Io's orbit around Jupiter. Some people are expecting Io's volcanoes to do something like this, and it's not too surprising, lead author Catherine de Clear noted in a statement. But then there are other people who think the volcanoes are so complicated that they wouldn't necessarily follow these orbital trends. De Clear and her colleagues started by pinning down the details of Io's orbit, which takes about 1.77 Earth days. That's too fast for scientists to develop a nuanced understanding of the orbit's impacts using Earth-based telescopes, which can only observe when Io is in their line of sight. But there are other much slower cycles on the scale of hundreds of days that are embedded within that orbit as other moons pull at Io. Those cycles could also influence the tidal heating that the moon experiences. It's been this interesting search for patterns in the volcanic activity. Tidal heating should produce volcanism that follows specific patterns, de Clear said. So you should have volcanoes that are occurring at specific places on the surface and not at other places, and you might expect them to show specific patterns in time also. As they tried to make sense of the volcano, the study authors gathered all the observations they could find of Loki over the past 3 decades. Much of that timeline scientists' data was sporadic at best, but in 2013, de Clear and her colleagues made a concerted effort to maximize observations of Loki. The result is the most detailed look scientists have ever had at the volcano's activity. It's the dataset which is the most impressive thing, Julie Rathbun, who wasn't involved in the new research but who also studies Loki, said in a statement. It's really hard to get all the data we want from the ground. The other factor that de Clear and her colleagues focused on was that the details of Io's orbit around Jupiter were less challenging to study. But it's not the sort of factor volcanologists might turn to first if they've been inspired primarily by volcanoes closer to home, which aren't strongly affected by any tidal heating. A lot of the geology is based on terrestrial geology, and there's not a lot of things on Earth that are driven by tides, so it's not something I think people, especially when studying volcanoes, are used to looking for, Rathbun said. When studying planets and moons, tides and periodicity are among the most obvious things to measure. They're the easiest things to measure. De Clear and her colleagues were inspired by cycles scientists who had noticed plumes streaming off one of Saturn's moons, Enceladus, which seemed to brighten and dim in conjunction with the moon's orbit. They found 2 cycles in Loki's activity that might be influenced by tidal heating, one lasting at 454 days and the other 480 days. Both of those numbers are close to cycles in which Io's orbit is tweaked by the influence of its neighbors. And realistically, that sort of cycle might make more sense in a volcano than a cycle tied directly to an orbital period as fast as Io's. Those are the timescales that a volcano can actually evolve on, de Clear said. She and her colleagues think one potential explanation for what's happening at Loki is that the plumbing of the volcano can't respond to tidal heating at the speed of the 1.77-day orbital cycle, leaving only slower cycles to affect the volcano. Understanding how Loki works isn't just about understanding one massive planet's weirdo moon. Earth and Io are the only worlds in our solar system where it's easy to study volcanoes, and Earth's aren't strongly influenced by tidal heating. But scientists believe that the phenomenon is a vitally important one in the bigger picture of planetary science in our solar system and beyond. This kind of global-scale, tidally driven geophysics is just not something that you have on Earth, de Cleer said. Io is kind of this alien world where we have these processes that you're not able to study on Earth. And if we can study them on Io, we can broaden our idea of geophysics more generally so that it's less Earth-centric and encompasses more worlds. De Cleer and her colleagues are hoping to continue regularly checking on Loki in order to sort out how Io's orbital cycles are governing its activity. They calculated when the volcano could rumble based on each timeline. Within a few years, they're hoping to gather enough data to pin down a better understanding of Loki's dynamics. It's going to be a lot of fun when we get close to the predicted times that the brightening should occur, de Cleer said. We can watch and we notice right away in the images when Loki starts to brighten, and that's always fun. And if it wasn't due to Voyager 1's exploration of Jupiter's moon, such a magnificent discovery would not have been made. But did you know that despite how Voyager 1 and its twin probe Voyager 2 were named, Voyager 2 launched before Voyager 1? It was launched from Cape Canaveral Space Launch Complex 41 aboard a Titan III Centaur on August 20th, 1977, and Voyager 1 followed suit on September 5th of that same year. While Voyager 1 primarily focused on Jupiter and Saturn, Voyager 2 visited both gas giants and then ventured onto Uranus and Neptune. However, the duo didn't stop there. Voyager 1 officially entered interstellar space on August 25th, 2012. While Voyager 2 entered on November 5th, 2018. The pair continue to journey through the cosmos and have enough power and fuel to keep scientific instruments running until at least 2025, according to NASA. But these space probes have already proved their worth, with Voyager 1 discovering a volcano on Jupiter's moon. Voyager 2 did even better when it captured a historic and breathtaking image of Neptune's rings on August 26, 1989. Before it was discovered, astronomers had suspected the planet Neptune, now categorized as the outermost major planet, had rings. After all, the next planet inward, Uranus, had rings found in 1977, as well as Jupiter's, which was found in 1979, and Saturn's. And watching from Earth in 1984, astronomers recorded extra blinks before and after Neptune passed in front of a distant star. They were caused by the ring material blocking the star's light. But it was NASA's Voyager 2 spacecraft that provided the first photographic proof of the existence of Neptune's rings on August 22, 1989. At the time, the spacecraft was a few days out from its closest encounter with the planet. As Neptune began looming large in Voyager's cameras, the spacecraft photographed a faint but continuous ring system encircling the planet. The images of Neptune's rings confirmed astronomers' long-held suspicions. Today, Voyager 2 remains the only earthly spacecraft to have encountered Neptune. But since Voyager's 1989 flyby, the Hubble Space Telescope and Earth-based telescopes have imaged the two brightest rings of Neptune. Astronomers named those two Neptunian rings Adams and Leverrier. They're named for John Couch Adams and Urbain Jean-Joseph Leverrier, whose independent calculations helped find Neptune's position in the sky, and this led to its discovery in 1846. The NASA Solar System Exploration also explained that there are names for three more rings of Neptune which were discovered later. Starting near the planet and moving outward, the main rings are named Gala, Leverrier, Lassell, Arago, and Adams. The rings are thought to be relatively young and short-lived. So today we know that Neptune has at least 5 main rings, plus it has 4 prominent ring arcs. The arcs are peculiar clumps of dust, and astronomers struggle to understand their existence because the laws of motion predict these arcs should spread out into a uniform ring over short timescales. Scientists now believe that the gravitational effects of Galatea, a moon just inward from the ring, confine the arcs. There are also 4 prominent arcs located in the outermost rings, and they have names too. Astronomers call them Liberté, Égalité, Fraternité, and Courage. They're located in the outermost ring Adams. Now, during Voyager's encounter, the engineering team carefully changed the probe's direction and speed so that it could do a close flyby of the planet's largest moon, Triton. The flyby showed evidence of geologically young surfaces and active geysers spewing material skyward. This indicated that Triton was not simply a solid ball of ice, even though it had the lowest surface temperature of any natural body observed by Voyager, which is minus 235 degrees Celsius. This discovery made by Voyager 2 opened the eyes of humanity to explore space further, as NASA expressed a further interest in going back to Triton and studying it more. The NASA flyby mission, dubbed Trident, may be rife with liquid nitrogen geysers in its southern hemisphere, or at least that's what was revealed on NASA's Voyager 2 mission's closest approach to Triton in 1989, when it captured a beguiling mosaic of images from this frozen world. If so, a 2038 Trident flyby could tell us a lot more about the source of this volcanism. Scientists and even geologists are particularly interested in how Triton's bizarre landforms are created and whether this strange moon contains an ocean. This inquisitiveness is part of the great steps leading to a leap in humanity's space exploration, and in the process, it created another historical experience by Voyager meeting Uranus. On January 24, 1986, the Voyager 2 spacecraft swept past Uranus, the solar system's remote seventh planet. The craft came within 50,640 miles, 81,500 kilometers, of its icy blue-green cloud tops. As a result, Voyager 2 became the first and so far the only human craft to visit this planet. During its closest approach and in the weeks before and after, Voyager 2 transmitted a treasure trove of scientific data that utterly changed our view of this enigmatic, distant world. Many remarkable discoveries came from this cosmic meetup. Data from Voyager 2 revealed that a Uranian day is just 17 hours and 14 minutes long. It showed that Uranus's atmosphere is similar to that of other gas giants composed mainly of hydrogen and helium. Below that lay water, ammonia, and methane ice. Now, scientists knew from telescopic observations made from Earth before Voyager 2 met Uranus that the planet's rotation axis was tilted at 98 degrees. In other words, the planet's polar axis lies almost in the plane of its orbit. Scientists think a collision with a planet-sized object early in the solar system's history tipped Uranus on its side. As a result, Uranus has perhaps the most interesting seasonal patterns in the solar system. Voyager 2 also revealed that Uranus has a bizarre magnetic field. The planet's magnetic field tilts 59 degrees from Uranus's axis of rotation, and it creates a non-uniform magnetic field for Uranus that can vary in strength by up to 10 times. Voyager 2 found that Uranus has radiation belts similar in intensity to those of Saturn. Earth also has radiation belts, with the two main ones known as the Van Allen belts. And Voyager 2 met not only Uranus but its many moons. Initially, scientists discovered 10 new moons in the data Voyager 2 sent back, for a total of 15 moons known at the time. But in 1999, additional analysis of Voyager 2 data revealed an 11th moon. Today, we know of 27 moons orbiting Uranus. Among the newly discovered moons was Puck, just 160 kilometers in diameter, with a gray, heavily cratered surface. Voyager 2 also imaged the Uranian moons we already knew, revealing their amazing geology. The last Uranian moon discovered before Voyager 2's arrival was Miranda. Gerard Kuiper found it in 1948. But thanks to Voyager 2, we saw Miranda much more clearly. In fact, it earned the nickname Frankenstein Moon because of its strange patchwork appearance. And by the time Voyager 2 met Uranus, scientists had already discovered Uranus's rings from Earth. Voyager 2 surveyed Uranus's rings and discovered 2 new ones, bringing the total number of rings to 11. Today there are 13 known rings. And so Voyager 2 vastly increased our knowledge of Uranus and then left this world behind for one final rendezvous with Neptune in August 1989 before heading out of the solar system. In December 2018, NASA announced that Voyager 2 had entered interstellar space. Now, 44 years after it launched from Cape Canaveral in 1977, the spacecraft is almost 19.3 billion kilometers away from home. This iconic Voyager 2 encounter still remains relevant today as scientists keep on studying it. And in the process, they uncovered a new mystery about Uranus's rings buried deep in data from NASA's iconic Voyager 2 mission. Voyager 2 flew past Uranus in January 1986, discovering 10 moons and 2 rings while becoming the first and so far only spacecraft to visit the ice giant. One of those rings, which scientists called the Zeta Ring, has frustrated astronomers ever since. They weren't even able to spot it again for nearly 2 decades. But last year, researchers got an unexpected gift, a new image of Uranus's ring system, including the elusive Zeta Ring. For a long time, we thought we only had 2 images of this ring from Voyager 2. Matthew Hedman, a planetary scientist at the University of Idaho, said during a presentation at the annual meeting of the American Astronomical Society's Division of Planetary Sciences. This shows there's a lot of information still encoded in the Voyager data that deserves a second look. Scientists originally missed the find because the reddish dusty ring closest to Uranus wasn't visible in any individual image, so Regan had to combine a host of images together for the feature to appear. He took hundreds of images, stacked them together to produce this image of the Uranian system, Hedman said. This is the most comprehensive view of the Zeta Ring that exists, and we didn't know it was in the Voyager data for decades. The new image, combined with the previous 2 Voyager photographs, offered Hedman and his colleagues enough information to calculate the ring's distance from Uranus, about 37,000 kilometers above the planet, and to estimate its brightness. But both of those values are puzzling. The Keck Observatory in Hawaii had gathered the first observations of the Zeta Ring since Voyager 2 in 2007. These observations showed the ring at 40,000 kilometers above the planet, a bit further from Uranus than the Voyager 2 observation showed. The trick is that the location of this ring didn't match the Voyager images, Hedman said of the Keck observations. Something had changed about this ring over the course of 20 years. We're still not entirely sure what that was, though. And the Zeta Ring didn't just inch away from the planet during those 2 decades it went unmonitored. It also registered a stronger signal in the Keck observations than it had in Voyager 2's view. It got significantly brighter, which means dust got introduced to the system sometime in those 20 years, Hedman said. Now, why did that happen? We have no idea. Hedman suggested that Uranus could have been hit by a space rock that fragmented into debris and settled into the Zeta Ring, or that perhaps the changing seasons could be responsible. But both are merely ideas. Whatever happened must have been dramatic enough to affect the rings, but also have slipped under scientists' radar. NASA will begin planning a major mission to explore the Uranus system in the coming years, but scientists won't have data from that mission for a couple of decades. However, Hedman noted that the James Webb Space Telescope had captured a dazzling image of similar rings around Neptune, released in September. Fortunately, there is a telescope that seems to be very good at looking at dusty rings around planets, he said, so that might be nice. Discoveries made by these twin interstellar space probes are definitely one for the books, and the pictures taken by them just cement the value they have added to the world of science and astronomy. It also helps scientists to study the final frontier better, especially with the discovery of an active volcano located on Jupiter's moon. Hold on, if we can see bizarre photos like an active volcano spewing lava into space, then what if there are more weird photos that NASA is hiding away from the public? What do you think? Let us know your thoughts in the comments section below.